Okay, for example 10, find an equation of the tangent line to the parametric curve x is equal to 2 times the sine of 2t, y is equal to 2 times the sine of t, at the point square root of 3, 1. Where does this curve have horizontal or vertical tangents? Okay, before we go any further, let's go ahead and graph this on Desmos. Okay, since we're dealing with the sine function, let's keep in mind here that we know that the value of t is going to have to be in between 0 and 2 pi. Okay, since we're dealing with the sine curve. So let's go ahead and take a look at this. So here, when we have parametric equations, keep in mind that we're going to write that as an ordered pair. So the x part of the ordered pair is going to be 2 times the sine of 2t, comma, it's going to be 2 sine of t. Okay, now again, since it's a sine function, we're going to go from 0 to pi. 2 pi, excuse me. And therefore, this is what our function looks like. Okay, and then we also want to figure out, okay, find the equation of where it is relative to this point of the square root of 3 and 1. So the square root of 3 and then 1. So there is the point. Okay, and we want to find a line that's tangent to that. All right, so we'll come back to Desmos, but this is just an idea of what this graph looks like. Now, we have our equation or formula number 7, okay, over to the right here. And so what that tells us is that if we want to find the derivative with respect to x here, the dy over dx, when we talk about parametric equations, we want to find dy of dt over dx of dt. Okay, so this is dy with respect to t. So that means that we want to find the derivative of the y parametric function. So we want to find dy of dt of the function 2 times the sine of t divided by dx of dt. So we're finding the derivative of the x parametric equation, which is the sine 2 times the sine of 2t. So now, when we find the derivative of 2 sine of t, well, we know that the derivative of the sine of t is the cosine of t. So that's going to become 2 times the cosine of t. Okay, and then in the denominator, we want to find the derivative of 2 times the sine of 2t. So the derivative of the sine, which is the outside function, is going to be 2 times the cosine of 2t. And then we got to find the derivative of the inside function, which is 2t. And the derivative of 2t is 2. So now we can then simplify this just a little further. So we can simplify the 2's. And so what's left is the derivative, which is the cosine of t over 2 times the cosine of 2t. Okay, so there is our derivative. Okay, now the next thing that we want to do is now we need to look at the values of x and the values of y here. So if we take a look at this first one, we know that we have 2 times the sine of 2t, and that's equal to x. So we need to look at the x-coordinate here. So the x-coordinate is the square root of 3. So we're going to replace this x to be the square root of 3. And then we're going to solve for t. So we have 2 times the sine of 2t, and that's going to equal the square root of 3. And so now if we divide both sides by 2, we have the sine of 2t, which is equal to the square root of 3. Okay, And then we want to find the inverse sign. So that means 2t is equal to the sine inverse of the square root of 3. And so the sine inverse of the square root of 3 we know is pi over 3. And then if we want to solve for t by dividing both sides by 2, that means that t is now going to equal pi over 6. Okay? Likewise, what we want to do is the following. So, now that we were able to find that t is equal to pi over 6, then we're going to use y, which is equal to 2 times the sine of t for our parametric equation. So y is going to equal 2 times the sine of the pi over 6. Well, the sine of pi over 6 is 1/2. And so therefore y is going to equal 1. So now we determine what t is and what y is. Okay? And so now that we know what t is, we can now substitute it into the slope or the derivative, because the slope is equal to the derivative where t is equal to pi over 6. So let's go ahead and plug that in. So we have the cosine of pi over 6 divided by 2 times the cosine of 2 times pi over 6. Okay? So we know that the cosine of pi over 6 is the square root of 3 over 2. And then this becomes 2 times the cosine of pi over 3, because 2 divided by 6 is pi over 3. So the cosine of pi over 3 is going to give us 1/2. So therefore this becomes the square root of 3 over 2 divided by 1, which means that our slope is the square root of 3 divided by 2. So now what we want to do in step number 4 is we want to find what is that line. Well, we know that we want to use the point slope form. Y minus y1 equals m times x minus x1. Okay? We know that our point is the square root of 3, 1, and we know that our slope is the square root of 3 over 2. So let's plug that in. So we have y minus 1, which is equal to the square root of 3 over 2 times x minus the square root of 3. Okay, so there is our line. So now what we want to do is we found the equation of our line. So that is the line that is parametric to that curve. So let's go ahead and put that into our Desmos. So we know that it should pass through that point. So let's go ahead and put that in there. So we have y minus 1, which is equal to the square root of 3 divided by 2 times x minus the square root of 3. So now we should see what that graph looks like. So there is our graph. So now we want to find the horizontal and vertical tangents. Okay, so if we want to find the horizontal and vertical tangents, we need to again look at the derivative of the function. So remember, the derivative of the function was equal to the cosine of t divided by 2 times the cosine of 2t. Okay, so if we want to find the horizontal tangents, then that means that we have to let the numerator equal 0. So we have the cosine of t, which is equal to 0. Okay, so what are the values of when t is going to equal 0? Well, let's go ahead and recall what that graph would look like. So if we had the cosine function, okay, and so our cosine function starts here, it goes to 1, and it goes down through here to -1, and then back up here, and then back through again. Okay? And so when we're talking about the cosine function, this point right here represents pi over 2. We know this point here represents 3 pi over 2. And this point here represents 5 pi over 2. Okay? And so with the horizontal tangents, okay, we have to let cosine of t is equal to 0. So that means that t is going to equal pi over 2 plus k pi. So that means that t is going to equal pi over 2 and 3 pi over 2. So that means when it's pi over 2, the ordered pair is going to be 0, 2. And when it's 3 pi over 2, the ordered pair is 0, -2. Now, let's take a look at the vertical tangents. So now we want to look at the vertical tangents. The vertical tangents means that we need to take the denominator, which is of the derivative, which is 2 times the cosine of 2t, and we're going to set that equal to 0. Okay, if we divide both sides by 2, we get the cosine of 2t, which is equal to 0. Okay, and then 2t is going to equal, the cosine inverse of 0 is going to be pi over 2 plus k pi. And so let's take a look at that graph. Okay, so if we want to graph cosine of 2x on here, let's just see what it looks like. Cosine of 2x. Okay, we have pi over 4, we have 3 pi over 4, 5 pi over 4, 7 pi over 4, and then it becomes 9 pi over 4. So let me go ahead and copy that. Okay, so very similar to what we just did in the previous example with our graph up here. And so if you notice, okay, over here we're using pi over 2, 3 pi over 2, and then this becomes 5 pi over 2. All right, so when we have 2t, which is equal to pi over 2 plus k pi, that means that now when we divide by 2, we end up getting pi over 4 plus k pi over 2. So what are the values of t on our graph? Well, we know that we have pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4. Okay, now what do these represent? Well, we know that pi over 4 is going to represent the point 2 square root of 2. Okay, 3 pi over 4, we have -2 square root of 2. 5 pi over 4 is 2 negative square root of 2. And 7 pi over 4 is -2 and negative square root of 2. So therefore, those are your vertical tangents. So your vertical tangents and your horizontal tangents.